Alright, so this is our Unit 1 review for our algebra classes. So we're going to solve linear equations. This was TEKS 5A. Variables on both sides. We're going to combine like terms. We're going to hippity-hoppity distributive property. We can also solve real-world application problems involving solving equations. So let's just start off with number 1 here. And here we go. I'm going to draw my line. Whoa. There we go. I'm going to look on the left and I'm going to see. I like to cover it up and see, is there anything over here I can put together? And there is. They're both B's. So I'm going to remember that there's a 1 right here. 2B and 1B will give me 3B plus 6 equals 21 minus 2B. These are different families, so I'm just going to say 21 minus 2B. I need to put all my B's on one side and my numbers on the other. I tend to always go left with the variable, right with the numbers. So I'm going to start. I'm going to move 2B over here plus 2B. I'm going to draw my line. 3B and 2B is going to give me, I don't know why that marker keeps doing that, 5B. Over here they're going to cancel out. Now, because I don't have a lot of room, rather than writing the next line, what I'm going to do is in the same spot, I'm going to move 6 over. Okay. So those are going to cancel. 21 minus 6 is going to give me positive 15. And now I've moved everything where it needs to go on this one line. Well, to get the 5B, this is multiplication. The inverse of multiplication is division. So to get that 5 away from B, I need to divide. 5 over 5 will cancel out, and B will equal 3. And there's my answer. Okay, let's try the next one. Let me zoom in just a little bit. Go ahead and draw your line and be working, getting it set up. I notice parentheses, so I'm going to be thinking hippity-hoppity distributive property. I'm going to give you 10 seconds to go ahead and get that going. I'm going to go ahead and start drawing it. Four times 3 will give me 12x, and 4 times 9 will give me 36, equals negative 3 times 6 and negative 3 times negative 2. Negative 3 times 6 is negative 18. Negative 3 times negative 2 is a positive 6x. Now I need to move everything. X's to the left, numbers to the right. So I'm going to start, I'm going to move that 6x. It's positive, so I need to subtract. $12 minus 6 is 6x. This cancels out. On that same line, I'm going to move these numbers. So this 36 needs to go over here, so I'm going to subtract 36. Subtract 36. Those will cancel out. Equals 8 and 6 will give me 14, 3, 4, 5, 54. To undo multiplication, the inverse of multiplication is division. And divide both sides by 6. X is going to equal, those cancel, 54 divided by 6 will be 9. Alright, on to the next one. I'm going to give you just a minute to start on that one. You do have some hippity-hoppity in here. Only this time I've got a 4 first, and then I've got this negative 2. So it's going to be negative 2 times 5 and negative 2 times negative 3n. So we're going to start, we're going to write the 4. Negative 2 times 5 will be negative 10. Negative 2 times negative 3 will be positive 6n. Equals 6 plus 5n. Now, I notice I have 3 terms on this side. When I have 3, that means there's probably something I can smush together. You're looking at that, you're like, oh, 4 and 10, those are just numbers. So 4 minus 10 would be negative 6. And remember, when we put that in our calculator, it looks something like this. 4 minus 10. Not 4 negative 10, it's 4 minus 10. Plus 6n equals 6 plus 5n. I'm going to put all my n's on the left and my numbers on the right. So I'm going to subtract 5n, subtract 5n. 5n's are going to cancel. 6 minus 5 is 1n equals, and on that same line I'm going to move this negative 6 over here, so I'm going to add 6 to both sides. Those will cancel out. 6 plus 6 is 12. So 1n equals 12, or n equals 12. There we go. Alright, let's take a look at number 4. Oh, look at the decimals. Don't let the decimals throw you or scare you. It's still just numbers. Alright, so there's an E in here. So E on the left, numbers on the right. What's on the E side that I don't want? 6.2, so I'm going to move negative 6.2. This will cancel out. And we'll, you know what, we'll just use our calculator. I can already see what it's going to be, but we're going to put it in there. So there it is. We're going to do negative 3.8 minus 6.2. Negative 10. So this right here is negative 10. Now, I'm going to move the E right here over here. So it's negative, so I need to do the opposite of it, 2.7e. I add it over here, so I'm going to add 2.7e over here. These will cancel. 2.3 and 2.7. Do you already see what it equals? 2.3 plus 2.7. Alright, so this is 5e. In order to get the 5 away from the e, I'm going to do the inverse operation, which is division. So e will equal negative 2. We're going to solve this one for x. I am not going to work this one all the way, but I am going to draw the line and get you started. I see a lot going on this one, right? It's taking a little bit of each of the ones we've done and putting it all together. I notice on this side there's 3 terms. If there's 3, there's probably something that's going to go together. Do you see what it is? Okay, go ahead and put those together. 3 and negative 5 are going to go together and give me negative 2x. So it's going to be 18 minus 2x equals, over here on the right, we're going to have to hippity-hoppity distributive property. So you're going to have 18 minus 2x. So, do you notice anything on that one? What if you were to put the x's on both sides first? You'd have negative 2x plus 18 equals, and put that 2x over there first, negative 2x plus 18. They're the same on both sides. Do you remember what we say when they're the same on both sides? I'm going to write it. Negative 2x plus 18 and negative 2x plus 18. When it's the exact same thing on both sides, that means any number we pick is going to work. This is what we call all real numbers, Any number we pick will work, all real numbers. And sometimes we say infinitely, I don't think I spelled that right, many solutions. Can't remember if it's E-L-Y. Alright, so now let's look at number 6. So on number 6, I'm going to draw my line. Alright. Give you a second to look at that one. Same thing, right? You got 3 on the left. 3 terms. What can I put together? Alright. So you're going to put 5z and negative 8z together. You're going to get negative 3. So negative 16 minus 3z. On the other side, ooh, look at this. This does not have anything in the front of it. I need to remember that this is a 1. Negative 1 times z and negative 1 times 5. So work that one. See what you get. You may want to pause your video. I'll work a little bit of it. Negative 16 minus 3z equals negative 10 minus 1z minus 5. Now on this side, I can put negative 10 and negative 5 together. Alright, I'm going to leave that one with you. Pause your video so you can work the next one. Okay, hopefully you finished number 6. We are going to solve for y. So, I don't think I'm going to work this one either. I'm going to get you started, but I'm going to let you finish it. I'm going to hippity-hoppity distributive property a whole bunch of times. So 5y minus 20 minus 19y equals negative 14y minus 7. That's a 14 right there. Sorry, I know it's kind of messy. There are 3 terms over here. I'm going to put the 5y and the 19y together. So negative 20, negative 19, and 5 is going to be negative 14y equals, oh, look at this, negative 14y minus 7. Do you see what's going to happen? I'm going to move my y's over here, my numbers over here. So I'm going to add 14y to both sides. What's going to happen? Can you tell? That's gone. That's gone. Those are 0. That means that what I'm left with is negative 20 equals negative 7. Can that happen? No. That is a false statement. I'm going to write the word false. So if I get a false statement, that means there's no answer. So that means if there's no answer, there's no solution. Remember when we got a true statement, like we did in number 5, that was all real numbers or infinitely many solutions. But when you get a false statement, that means there's not anything that's going to work. Alright, Val measures the perimeter of her rectangular garden as 80 feet. The width is 3x plus 1 and the length is x minus 5. What is the length and the width in feet? Okay, so Val measures the perimeter of her rectangular garden. So I'm going to draw a rectangle. I'm very visual. I like to see it, and if I can see it, I can usually figure it out. So it has the width of 3x plus 1. I think I probably drew the rectangular garden backwards. And a length of x minus 5. I think it's probably meant to go the other way. Okay, so if the what is the length and the width? I know that the perimeter is 80. Remember, perimeter equals twice the length plus twice the width. Or, if that's a hard formula for you to remember, just remember you start on a corner and you walk. I just walked x minus 5. I just walked 3x plus 1. How far am I walking here? Yeah, x minus 5. I'm going to keep walking. And that's 3x plus 1. So I just walked all the way around the garden. And I know the garden is 80 feet. Okay, well, let's add it up. 1x, 3x, that's 4, 5, 6, 7, 8 x's. Now, because there's so many, I'm bad about this. I will mark it off. Otherwise, I'll forget. Negative 5, that's negative 10. Plus 1 would be negative 9, plus another one would be negative 8. Now, if you're like, whoa, that's a lot of math in your head, let's do this. Let's do negative 5 plus 1 minus 5 plus 1. Just put them in your calculator. Negative 8. Negative 8. And it equals 80. Remember that perimeter problem we did on that Freyer model? I told you I'd come back to haunt you. I'm going to add 8 to both sides. So 8x equals 88. Inverse here, divide both sides by 8, and x equals 11. Now, let's go back and double check. We did a lot of math there, but did we answer what they wanted to know? The question is, what is the length and the width? What is the length and the width? I didn't find the length and the width. I just found what x was. So I need to go back in here, and I need to put that 11 here for x. What's 11 minus 5? Yeah, it's 6. So that means this side is 6. What is 11 times 3? That's 33. Plus 1 is 32. Yeah, I definitely got my figure drawn wrong. 32. So what is the length and the width? Well, we need to write it out. Let's see, the width is 3x plus 1. So here's my width. So the width is 32. I would count off if you had these labeled backwards. And the width, or length, is x minus 5, which is this right here. So it's 6. Oops. Here's my answer. Okay. The cost of t-shirts, RS to make shirts is a setup fee of $25 plus $5 per shirt. The cost of shirts for less, oh, these are the names. Oh, okay. T-shirts RS and shirts for less is $50 to set up and $4 a shirt. When would the cost be the same? You remember that LA Fitness problem we did? No, not the LA Fitness, the hoverboard. I was like, what was that we were doing? Hoverboard. And we had to see, and we were saving up money, and we had to compare it. When would the cost be the same? Same just means equal. Okay, T-shirts RS. To make shirts, $25 to set it up. Plus, what are they charging? $5 for every shirt. So let's do $5. We'll say X for every shirt. Shirts for less is charging $50 just to set it up. But they're only charging $4 per shirt. So when would this be the same? When would it be safe to go either route? Okay, well, let's see. I'm going to draw my line. I need to get all my X's on one side, all my numbers on the other. So I think I'm going to move this 4X first. Those will cancel out. And I'm going to have 1x equals, and I still have this 25 and the 50. So I'm going to come up here and I need to move. This is my x side, and I don't want that 25 there, so I'm going to move that 25 over. 50 minus 25 is 25. Oh, so right here, 1x. So that just means when x equals 25. So let's double check that. Let's say, okay, what if it is 25? So 25 plus 5 times 25. So let's do this. 5 times 25 plus 25. Well, you can't see it. 150, right? And on the other side, 50 plus 4 times 25. So at 150 shirts, right? When x is 150. So that means at 150 shirts, they are equal. Or they are the same cost. Okay? At 150 shirts, they're the same cost. Which company would you choose if you needed more than 30 shirts? If you needed more than 30 shirts, well, I mean, I guess it depends on how many more than 30 I need, right? If I needed 30 shirts, so, oh, I'm sorry, right here. This is 25 shirts. I did that wrong, didn't I? I messed that up. At 25 shirts, they're the same, not 150. 25 shirts, they are the same cost. But it's going to cost you 150. I was doing that backwards. At 25 shirts, the same. So if you only need 30 shirts or more, which one are you going to pick? Yeah, I'm going to pick this one. Because at 30, let's see what 30 shirts. 30 shirts. Let's do t-shirts. I'm going to put RS. If we put 30 in right here. So 25 plus 5 times 30. Because we're doing 30 shirts. They're costing $175. T-shirts RS. It's going to cost me $175. Now let's do shirts for less. Let's use this side. 4 times 20. Nope, times 30. Plus the $50 setup fee. They're only going to charge me $70. $170. So for 30 shirts or more, for less is going to be cheaper. So I would choose shirts for less. Because it's cheaper. There we go. Okay, number 10. Mrs. Mayberry showed this example to her students, and it was called My Favorite Note, because she said it showed a common mistake students make, but the rest of the math was wrong. What is the mistake? Alright, have you found it? I'm going to put a -1 here. -1 times 2 is -2. -1 times -5. Yeah, right here. That should be a positive 5x. 1/2 of 4 is 2. 1/2 of 8 is 4. So right here, they made an error. And that is when you distribute, a negative times a negative is a positive. When you distribute a negative times a negative, equals a positive. All right, and that is TEK 5A. All right, so you also have for this test, you have TEK 5B, which is the other one we did. So on that one, let's try and put this up here. I can solve linear equations, variables on both sides. Actually, that should be I can solve linear inequalities. Combining like terms, distributive property, I understand my solution represents. So this right here should say inequalities. Okay, so here we go. Solve each inequality and graph your solution. So hippity-hoppity distributive property. 4k minus 20 plus 12k less than or equal to negative 4. When you have three terms on one side, we know we can put them together. 12 and 4 will give me 16k minus 20 less than or equal to negative 4. I'm going to move that 20. I'm going to add 20 to both sides. 16k equals 16. I'm going to divide both sides by 16. K equals, I said equals, didn't I? Look at that, I'm making that error. There we go. K is less than or equal to 1. Do I need to flip the sign? No, I didn't divide by a negative or multiply by a negative, so I'm not changing their place on the number line, so I don't have to do anything there. So it's just K is less than 1. So remember to graph it. I go to whatever number's here and I circle it. It has the line underneath it, so that means I'm going to color it in. It points this direction. It's pointing to the left. So that means I'm going to shade to the left. There we go. All right, number 2. I'm going to draw my line. Negative 2x. Here's that common no that she was saying a while ago. Negative 2 times negative 6 is positive 12. Less than 8. X side, number side. We're going to move that 12 over. Now I'm subtracting. Do I need to flip the sign? No, because remember we discovered that adding and subtracting, it didn't do anything to the problem. You can add and subtract whatever you want. It's only when you multiply or divide that things happen. So let's get that negative 2. Now I am dividing by negative. That means on my number line they're swapping places, which means this is going to have to flip. So I'm going to circle it, and that's going to leave me with x. I'm going to flip the sign. Negative 4 and negative 2 will give me a positive 2. So I'm going to circle the 2. It's only greater than, it's not equal to, so I'm going to leave it alone. It's pointing that direction to the right, so I'm going to shade to the right. There it is. All right, 13. I'm going to hippity-hoppity. I'm going to actually let you do that one, I think. I'll get you started. 3x plus 12 greater than 4 minus x. Move the 12, and I'll let you go from there. Remember, if you divide or multiply by a negative, you have to flip the sign. So pause your video so you can finish that one, and I'm going to go on to 14. All right, I see a whole bunch of stuff over here. What can I put together? (2x) and negative 8, and then I can put negative 13 and positive 5 together. Once I put those together, then I can move and make this my x side and this my number side, and I can solve it. Okay. Negative 8 and 2 will give me negative 6x. Negative 13 and 5 will give me negative 8. Greater than or equal to negative 7. Okay, go ahead and finish that one. Okay, so hopefully you finished those last two. Without solving, how do you know, I'm going to put it here, negative 5r plus 6 is greater than or equal to negative 5r minus 10. Has infinitely many solutions. Okay, here's how you know this. These are just the same, right? Negative 5r and negative 5r. And then you just have 6 and negative 10. Is 6 bigger than negative 10? Yeah, it is. 6 is greater than or equal to negative 10. So how do I know that? Let's say this. The 5 or the negative 5r cancels out. And I have 6 is greater than negative 10. A true statement. So no matter what I do to that equation, no matter what I add or subtract, any number I put in there is going to work. Let me pull that out some. Any number I put in there is going to work. So that means I have infinitely many solutions. All right, last one. How do you know when you change the direction of an inequality symbol? Oh, that's pretty straightforward, right? When you divide or multiply by a negative number. So I will let you write that in there. You can do that. And that concludes our review. We're going to do literal equations at a later date. Thanks for watching.